most of our herbicides or insecticides and fungicides are uniquely poor for controlling things in the soil, whereas microwaves can get down into the soil and kill biological organisms reasonably deep, down to 10 centimetres or so. So for things like seed banks, which I'm particularly interested in, being a weeds type person, microwaves provide a real opportunity to get things under the ground. Most of many of your cropping problems you can see in the grain as it's being harvested. You've got weeds, you've got ryegrass, brome grass, oats, radish, mustards, turnips, catchfly, bedstraw, and things like cleavers and goat grass and patches of resistance, which you probably don't know are there. You can pick those up relatively easy, even if you don't recognise them. Insects include the armyworms and budworms and earwigs and locusts and weevils, snails, and then there's a bunch of diseases which are also quite easy to pick up sort of in grains, and these are basically things that cause some sort of marking on the grains, like the ergots and the black points, or the pink fusarium makes the grain go pink, the smuts and the rusts and the ergots and all those sorts of things. So there's a whole range of problems you can't pick up, but there's a whole range of problems you can pick up. And even if it's just looking at shriveled grain to look for root rots in the paddock, you can just look for shriveled grain, and if you've got a shriveled grain map, that might sort of encourage you to go and search for root rots or do something about root rots in those areas, or look for mildew or something of that order. This is where we sort of basically from. Sort of originally we just used to sieve things and float them and do them out in the paddock, sort of next to the Hannaford grader. Then we sort of went into the lab and was using sort of an SLR machine and just taking photographs down there and doing image analysis on that, simply because you can do a lot more of that sort of stuff a lot quicker than you can do it sort of out in the field. And then eventually this has been motorised, I suppose, to have a little machine here which is just a belt here, so just a conveyor belt. You pour the grain on the top, it's sort of spilt out onto the belt very slowly. Video recorder there, a couple of lights, so you've got control of your lights to look at your video. It's all just visible stuff, because visible detectors are far cheaper than any other sort of detector, and that goes off into a computer and then just basically says, I found a particular weed seed. In this case we're looking for bedstraw and grain, and then at the bottom end here we've got a bunch of drafting gates, so it'll just draft the bedstraw into one bucket and let the clean grain go into the second bucket. So this is just a drafting gate type machine. And the good thing about this is we can go through tons and tons of seconds or sample, whereas to do that by eye, I'm going to say when we've got the concentrated sample, we still go through by eye to work out that there's bedstraw there. So it's not. I'm going to say looking at it's always better than the machine, but the machine can concentrate the sample up, so you've only got a cupful of grain out of sort of 1,000 tonnes of sample, and so that makes the process of searching for it so much easier. CBH have got right into this image analysis with their iPhos machines, and there is a FOSS demonstration tent out there. And again, it's the same sort of machine. That's this little blue thing there is the belt which is there. This is their detector here, which is our video up there. And this is a little funnel up the top there, which is our feeding funnel, and that just goes off the end. And again, from a grain sample there, you've got wheat, oats and barley and canola and clover and earwig heads and ryegrass and brome and wild oats and all those sorts of things we can distinguish reasonably easy. CBH at the moment have just taken on a contract with the industry funding scheme to look at bedstraw in CBH grain samples, and they've made up an algorithm with their normal iPhos machine, which looks for shriveled grain and all the various quality constraints, is also looking for bedstraw through. Well, this is looking through about 5,000 samples, which means we can survey stuff far more efficiently than we ever could before. So that's basically the setup of what we've got lined up. So basically got the harvester produces the grain, little collector sort of collects about 1 kilo in a tonne, so it's taking a sample of it, normally goes through a bit of a sieve, across the transporter, which is normally a belt. There's a sensor here, and it can be any sort of sensor, but we tend to use visible light sensors because they're just cheap. That goes into a computer, and then if we feed the GPS and time into it, we can actually turn this into a paddock map. So if we know what the time was when the sample went through and what the GPS locations are, we can sort of calculate back that it took sort of 10 seconds or 15 seconds to come through the header and get to the machine, and therefore we can, within 10 or 20 metres or so, tell you where that particular insect or disease or noxious weed sort of came from, or snail in this case, to create a map. And once we've got the maps, we can then start feeding that into sort of precision agriculture type stuff, or patching, doing bait, controlling patches where we can use, say, quite expensive techniques. So you might, if you found a patch of resistant ryegrass, you might go out there and moldboard plough it, so you don't have to moldboard plough a couple of acres in your paddock rather than having to do the whole 1,000 acres. Initially we sort of start off to try and get some funding for looking at detection of three very different organisms. So we've got ryegrass, which is a widespread serious weed, and this is mainly Tim Harrington's input, who's been working in developing up these ideas, and it's really to monitor or benchmark how well his control programs are going and where he's losing it, or if he's losing on a particular soil types or one chemical's not working as well. So for this case, I'm say Blind Freddy can tell you there's ryegrass in the paddock, because there's ryegrass in every paddock almost, so you don't need an image analysis machine. But it's very useful in being able to say, is your control this year better or worse, or is it are you losing it in particular spots, or is non-wetting soil coming up, or is there nutrient deficiencies where things are happening? So he's very interested from a benchmarking point of view. From my point of view, it's really good for detecting patches of Roundup resistance. So resistance always occurs in patches, and Roundup resistance will occur in very small patches at very low frequencies. So if you can get out there sort of on the day when it occurs, or the 1 or 2 years after it occurs, you can go out there and do something serious about taking that hectare out and saving the rest of the farm, because most of your Roundup is going to be spread by you spreading resistant seed around rather than sort of developing in situ. So it's quite different to Group A and Group B and Group C resistance. Roundup resistance will occur in very small patches, and if you can pick up those early, then you can save yourself from having it all over the farm. The other reason for doing it is to take noxious weeds like bedstraw, and the main reason for doing this is that very few people recognise bedstraw if it come up and bit them on the bum. You know, you see lots of odd little seeds and things in the grain. You've got no idea whether they're important or not, and this sort of technology just allows that to be out there detecting the bedstraws and the cleavers and the goat grasses, and even in skeleton weed there's a potential of picking those up, and then that can become a target for eradication. And again, sort of with the new paradigm of less people on the ground, you need to be able to target these things much better. Snails are an increasing problem, so that's why we've picked up on snails. And again, they occur in patches initially, and baits are quite expensive. So if you know where the patches are, you can go out there and just bait those patches rather than have to bait the whole paddock. And again, it's difficult to remember where they are or to find them. So they're very easy to see at harvest time, and very hard to find next May, June when you're planting your crop or planting your canola out there. So the spot it's at the moment is we've done most of the background work, and it's really just a spot where it needs to be developed into a prototype and make it robust enough to go on a machine. Second half of the talk's looking at microwaves killing seeds. It's probably got two actions: straight heat and protein denaturation. It's relatively expensive, so it's limited to niche and patches. We don't expect to have microwaves at the broadacre situation anywhere time in the near future. It's good for killing multi-resistant ryegrass, so anything that no herbicides to work on, microwaves work fine. And basically we've got nothing that's any good at killing weed seed in the soil. So apart from deep burial, if you've got a weed seed bank in the soil, you basically live with it until the dormancy's gone, and for things like gorse that can be 20 years or more. So there's a lot of work to actually eradicate these things, whereas microwaves can take out a gorse infestation in a single year. We can get down to about 10 centimetres, and very few weeds can germinate from deeper than 10 centimetres, so it sort of fits fairly nicely with the requirements of what's there. This is just looking at different seed states. If you look at this, the red line there is just wet seed, and you see wet seed we can kill in about 50 seconds. And if you've got dry seed, it takes us about 250 seconds, so it takes us a lot longer to kill dry seed than wet seed. And where that's important is that'll determine when you apply your microwaves. So what you want is you want wet seed in a dry soil. So that's basically at the end of the season when everything's drying out. If it was the other way around, you'd sort of do it at the beginning of the season when the soil's wet, because the problem with wet soil is it absorbs a lot of microwave power if you've got wet soil there. So what you want is dry soil with the wet seed in it. It's got no effect on ryegrass dormancy, but does affect gorse dormancy fairly dramatically. This is actually the machine we use. It's just a little sharp microwave oven, the same as you have on your kitchen thing. That's the last one that we blew out, because you blow them out pretty regularly. So that gives you a bit of a scale of size. And so basically it's just a microwave with a big funnel on it to take it out so we can shoot it at the soil. And the semi-commercial ones that Uni Queensland are doing has just got a metre wide one and then a much bigger magnetron on it. So that's basically the machine we're using. And that'll be the prototype we take into the field that'll go along at sort of about a metre per minute. So really slow times out in the field. To kill snails, and actually Paul did mention, and we're going to do a little video at the end of this, if you're a bit queasy about snails dying, or you haven't cooked snails before and you know how they sizzle and pop and you get snap, crackle and pop snails sort of things, now's probably the appropriate time to either avert your eyes or leave, because some people may find it confronting. Microwaves probably got two actions. There's straight heat, there's an internal damage, and we think we're actually killing them more by internal damage rather than the straight heat, because they don't actually get up to or cooked enough to be a heat job. Costs about $3 million at the moment, so it's not a big problem, but it's a growing problem, and particularly they're going a lot further inland than we thought, and it's mainly the conical snail rather than the Italian snail, which is the one on South Australia on the limestone soils. Our work's been done mainly on the larger garden snail because they're a lot easier to collect, etc. And small conical snails don't take bait, so things like microwaves are pretty useful because they're not that amenable to being hit by baits. Non-chemical, which is good for organic sort of people, and low levels of microwaving give pretty good levels of kill, and that's basically the amount of microwave across the bottom and the percentage survival up the edge there. And if you can see, once you've got to about 6 or 7 seconds, you're basically going to 100% control, and that's only at a temperature of 40, 45 degrees. So it's sort of a hot summer's day is sort of, so we think it's not the heat. There's something else going on there which is causing the death at rates so much lower. And there's probably some potential for bringing those seconds back, but that's reasonably easy. Okay, this is a little video we've got, and now the trick is okay, right. So there's this microwave being turned on there, so the. Oops, sorry. Do you start that at the back, do you? There you go. So, that's just a microwave horn that you saw at the top there. It's about an inch underneath. And as you can see, as the microwaves start coming in, they start to hit it, and then eventually, that's how they die. And as the microwave continues, they'll keep sort of so we have sort of poppers and sizzlers. This one here is a sizzler, and then this little section here is done in slow motion, and that's at 10 times slower. So even in slow motion, they do die extremely quickly. And this is another bunch here that are sort of just a different batch, and the little guy sort of crawling out the back there. He'll eventually get caught, and you can see these guys here all start going. It just seems to have lost the sound off this. There is sound associated with that, and then they'll start to pop. And this is another guy again. The sound came back. That's what they sound like. So if you're out there microwaving, you can actually hear what's going on. And at that point I'll probably do a runner or take questions.